Mr. M, I've been having a hard time getting girls to notice me lately. Any advice you can give me?
Absolutely not, Jimmy. But I can tell you a little bit about period 3 and group 13 of the periodic table.
Excuse me?
First, I will start with electronegativity. Electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. If an atom had a higher electronegativity than another, then it is more likely to attract electrons. As we move across period 3 of the periodic table, which includes the atoms sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon, electronegativity increases. This is due to the fact that elements closer to the right of the periodic table are closer to achieving valency than those closer to the right, so they are more likely to take electrons. The only exception is argon, which is a noble gas and does not need electrons. As we move down group 13, you will notice electronegativity seems to decrease. This is due to the fact that electrons in the lower energy levels towards the bottom of the periodic table shield the positive charge coming from the nucleus, making them less electromagnetic than the ones above it. In group 13, which includes boron, aluminium, gallium, indium, thallium, and ununtrium, the electronegativity goes up when you go from aluminum to gallium, then resumes its drop from gallium to indium. This is due to something called the d-block contradiction. The d-block contradiction essentially makes the electrons in gallium shield the charge of the nucleus less, making it more electronegative than one might expect. Next, I will discuss atomic radius. Atomic radius is the distance between the nucleus to the outmost electron of an atom. If we look across period 3, one will notice the atomic radius decreases as you go further to the right. This is because the charges within that atom are stronger due to the amount of electrons, so they are more attracted to the nucleus as the center of the atom. This makes the atom tighter. When one looks at group 13, they will notice the atomic radius goes up when going down the group. This is due to the fact that every time you move down a period, another energy level, or orbit around the atom, is added, which makes it larger.
Oh, okay. That's great stuff, Mr. M, but I know a few things about the melting points and ionization energy of group 3 and family 13.
Is that so? So explain to me, what is the purpose of ionization energy and the melting points of those groups?
Within period 3 there is a dot pattern that is represented in the periodic table. As the elements running in horizontal order beginning with sodium ending with argon appear, their melting points vary. Na's boiling point is 371, followed by an increasing amount. Then a sudden shift occurs at silicon having a 1683 melting point. Then the degree recorded in Kelvin returns to a low temperature ending with argon at a melting point of 84 degrees Kelvin. This cycle exists because many of the elements need a higher amount of energy input in order to change state. Meanwhile, the same effect occurs to group 13, beginning with boron, which has a melting point of 2573 Kelvin, but as you go down the group the amount of energy decreases then again increase.
Wow, I am surprised with how well you know your information. But could you now explain the ionization energy, cause I'm a bit confused by how it plays a role in the periodic table.
Mr. M, didn't you go to school for this? Shouldn't you be teaching this stuff to me?
Ha ha ha, you are right, but it doesn't matter. Continue, please.
Okay, ionization energy can be explained as is the energy required to remove electrons from gaseous atoms or ions. The ionization energy may be an indicator of the reactivity of an element. Ionization energy is also a periodic trend within the periodic table organization. Moving left to right within a period or upward within a group, the first ionization energy generally increases. As the atomic radius decreases, it becomes harder to remove an electron that is closer to a more positively charged nucleus. Ionization entropy increases from left to right in a period and decreases from top to bottom in a group.
Now I know that you didn't just teach yourself this. How did you find this stuff out?
I used my good old friend named Google.
I remember when I was in school I had to use the library.
You know what's funny about that? Because I think that was the same year dinosaurs walked the earth. Ha ha ha, get it, you're old.
You know what would be funnier? Me giving you a F for the year.
Not funny. But as I was saying, a great to understand ionization energy is to use Bohr example of the atom. What he was able to with its example was show the amount of energy needed to move one electron from its ground level to another level or shell. I haven't been able to find any information that gives a direct pattern for group 3 or family 13, but I think what I just told you is good so far.
Jimmy, I like the way you think.
Now what about ionic radius? What is that?
Funny you should ask, champ. Ionic radius is the distance between the center nucleus and the outer edge of the ion. The ionic radius is measured in picometers. 1 picometer equals 10-12 meters, but ionic radii are difficult to measure with any degree of certainty and vary according to the environment of the ion. For example, it matters what the organization of the ion is, which means to determine how many oppositely charged ions are touching it, and what those ions are. As you move down family 13, you notice that the ionic radii continues to increase. This is because additional layers of electrons are being added when you go down the periodic table, which naturally causes the ionic radius to increase.
Oh, thanks for clearing that up. Now what about the metallic character? That doesn't make much sense to me.
Well, my child, metallic character is a set of chemical properties associated with elements that are metals. These chemical properties result from how easily metals are willing to give up electrons. So basically it's the tendency of an atom to lose an electron and form a positive cation, making the atom positive. Just like ionic radius, there are inclinations in metallic character as you move across and down the periodic table. Metallic character decreases as you move across a period in the periodic table from left to right. This occurs as atoms more willingly accept electrons to fill a valence shell than lose them to remove the unfilled shell. Metallic character increases as you move down an element group in the periodic table. This is because electrons become much easier to lose as the atomic radius increases, where there is less attraction between the nucleus and the valence electrons because the distance between them becomes gradually larger.
Now that we got everything cleared up, how about those tips on how to get girls to like me?
Well, Jimmy, I'm sorry I can't help you with that. That's something science can't explain.
I'm so sad. The end.